These 5 objectives will be covered in 2 parts. At the end of this part 2 video, you should be fully able to define and give general equations for synthesis, decomposition, single displacement, and double displacement reactions. Classify a reaction as a synthesis, decomposition, single displacement, double displacement, or combustion reaction. List 3 kinds of synthesis reactions and 6 kinds of decomposition reactions. List 4 kinds of single displacement reactions and 3 kinds of double displacement reactions, and predict the products of simple reactions given the reactants. In a single replacement reaction, also known as a displacement reaction, one element replaces a similar element in a compound. Many single replacement reactions take place in aqueous solution. The amount of energy involved in this type of reaction is usually smaller than the amount involved in synthesis or decomposition reactions. Single replacement reactions can be represented by the following general equations, which are represented on your screen. A plus Bx reacts to form Ax plus B, or Y plus Bx reacts to form By plus X. And in these circumstances, A, B, X, and Y are all elements, and Ax, Bx, and By are all compounds. Aluminum is more active than lead. When solid aluminum is placed in aqueous lead 2 nitrate, which is PbNO3(2), represented on the screen here, the aluminum replaces the lead. Solid lead and aqueous aluminum nitrate are formed, again, according to the equation on the screen here. The most active metals, such as those in group 1, react vigorously with water to produce metal hydroxides and hydrogen. For example, sodium reacts with water to form sodium hydroxide and hydrogen gas, according to the equation at the top of your screen. Less active metals, such as iron, react with steam to form a metal oxide and hydrogen gas, according to the equation at the bottom of your screen now. The more active metals react with certain acidic solutions, such as hydrochloric acid and dilute sulfuric acid, replacing the hydrogen in the acid. The reaction products are a metal compound, which is called a salt, a metal compound, and hydrogen gas. For example, when solid magnesium reacts with hydrochloric acid, the reaction products are hydrogen gas and aqueous magnesium chloride, according to the equation on the screen here. In another type of single replacement reaction, one halogen replaces another halogen in a compound. Fluorine is the most active halogen. As such, it can replace any of the other halogens in their compounds. Each halogen is less active than the one above it in the periodic table. Therefore, in group 17, each element can replace any element below it, but not any element above it. For example, while chlorine can replace bromine in potassium bromide, it cannot replace fluorine in potassium fluoride. The reaction of chlorine with potassium bromide produces bromine and potassium chloride, whereas the combination of fluorine and sodium chloride produces sodium fluoride and solid chlorine, according to the equations at the bottom of your screen here. In double displacement reactions, the ions of 2 compounds exchange places in an aqueous solution to form 2 new compounds. One of the compounds formed is usually a precipitate, which is an insoluble gas that bubbles out of the solution, or a molecular compound, usually water. The other compound is often soluble and remains dissolved in the solution. A double displacement reaction is represented by the following general equation. Ax plus By reacts to form Ay plus Bx. And in this circumstance, A, X, B, and Y in the reactants represent ions. AY and BX represent ionic or molecular compounds. The formation of a precipitate occurs when the cations of one reactant combine with the anions of another reactant to form an insoluble or slightly soluble compound. For example, when an aqueous solution of potassium iodide is added to an aqueous solution of lead 2 nitrate, the yellow precipitate lead 2 iodide forms, according to the equation on the screen here. This is actually shown in your textbook or on the screen here. This reaction occurs according to the balanced equation shown on the screen here. 2Ki in aqueous solution plus PbNO3, also an aqueous solution, react to form PbI2, solid, plus 2KNO3, again in the aqueous phase. The precipitate forms, and in this situation it is the lead iodide. The precipitate forms as a result of the very strong attractive forces between the lead 2 plus cations, 2 plus, and iodide -1 anions. The other product is the water-soluble salt called potassium nitrate, which is KNO3. The potassium and nitrate ions do not take part in the reaction. They remain in solution as aqueous ions. The guidelines that help identify which ions form a precipitate and which ions remain in solution are discussed later in the course. In some double replacement reactions, one of the products is an insoluble gas that bubbles out of the mixture. For example, iron 2 sulfide reacts with hydrochloric acid to form hydrogen sulfide gas and iron 2 chloride, according to the equation at the top of your screen. In some double replacement reactions, a very stable molecular compound, such as water, is one of the products. For example, hydrochloric acid reacts with an aqueous solution of sodium hydroxide to yield aqueous sodium chloride and water, according to the equation at the bottom of your screen here. In a combustion reaction, a substance combines with oxygen, releasing a large amount of energy in the form of heat and light. The reaction's product is water vapor, according to the equation at the top of your screen. The burning of natural gas, propane, gasoline, or wood, are also examples of combustion reactions. For example, the burning of propane, which is C3H8, results in the production of carbon dioxide and water, according to the equation at the bottom of your screen here.
Methane, like many fossil fuels, can react with oxygen in a combustion reaction, releasing heat and forming carbon dioxide and water. The amount of oxygen available is very important for this reaction. When the supply of oxygen is limited, carbon monoxide, a poisonous gas, is formed. At very low oxygen levels, soot, or tiny pieces of carbon, are formed.
At this point, you should be able to fully define and give general equations for synthesis, decomposition, single displacement, and double displacement reactions. Classify a reaction as a synthesis, decomposition, single displacement, double displacement, or combustion reaction. List 3 kinds of synthesis reactions and 6 kinds of decomposition reactions. List 4 kinds of single displacement reactions and 3 kinds of double displacement reactions. And predict the products of simple reactions given the reactants.